Hey guys, welcome to our channel Coders Arcade. This is Ashank David. Good evening everyone, and in today's class we are gonna continue our DSA live session, and in today's class we will be talking about queues. In the last class we did stacks. In today's class we will be doing queues. So let us continue. So here first of all let me just open up my Microsoft whiteboard. Let me just open up this. Let's continue. So good evening everyone. Let me just start this, and today we are gonna do our DSA live, where we are going to talk about queues. Let us quickly revise what we have done in the previous class. We have finished till stacks. The very first data structures that we have talked about was stacks. The basics of stacks we have already understood. In today's class we are going to understand about the basic concepts of queues. So let's continue. Well, all right. So yesterday's class I was not able to come because of some issues, some technical issues and some other things that were happening. So now we have come after one day. So today is Thursday. I came last time at Tuesday. So on Tuesday we have understood about stack data structure. In that stack data structure we have understood what exactly is a stack, what is that data structure, how that works, how the data is stored into it, the concept of last in first out or first in last out. We have understood that in the stacks concept. We have understood how that the real life example works in that stack example, and we have understood how to code for it. We have used pointers, array pointers, we have used arrays, we have used dynamic memory allocation, we have used object oriented programming to do that thing. Now if you remember what exactly is a stack, this is gonna be very easy in today's class. What we are doing is queues data structure. So we will be focusing on to how that queue data structure works. Now queue data structure is very similar to what you see in stacks, where today also I am going to explain you about queues. So what exactly is queues? So queues, speaking of queues, let's take an example. In real life, you went to the airport or you went to a railway station, for example. So there you see that there is a large queue. Queue means the line of people standing in a queue. You know that queue, right? Let's say you are standing in the last position. Slowly as the queue is getting emptied, your number is coming towards the front of the queue. Queue is like this. So let's say this is let us say this is the ticket counter. Okay, this is the ticket counter window. People are standing here. Okay, people are standing here. Now there are multiple people standing in line. Okay, there are multiple people standing in line. Okay, let's say this is you. Okay, and you want to reach till the front of the ticket counter. Okay, what will happen? In this case, this is you, correct? So you will move forward. Let's say we are talking about this guy. This guy got his ticket. So he will leave from here only. I hope so that you are able to understand what I am trying to say. Correct? This guy, as soon as his job is done, this guy will leave from the front itself. You are standing here. Behind you, one more guy is standing. Now, this guy will move into your position and you will move into one position plus plus. Correct? Similarly, like this, you will keep on coming. These people will keep on leaving. Then you will reach here at some point of time. So you see, if you see here, people are entering from this side and exiting from this side. Correct? Am I correct? In this case, you see that people are entering from here and they are ending from the front. This is what a queue is. Incoming from the back side and leaving from the front side. According to this example, the theory of queue says first in, first out. Isn't it? Isn't it, guys? First in, first out. The guy who entered first will be served first according to its position. At some point of time, you were standing here, you will move here, then you will move here and you will move here. You will be served first. Are you getting my point? This is the concept of queues. First in, first out. You entered the queue first, you will leave the queue first. Because you will be served first according to the procedure. Am I correct? Yes, we have understood this. This is the concept of queues. Now, this is one example that I have shown you. Similarly, you can take many different examples. There can be many different examples. For example, a queue of students standing in a line in assembly of a school. You are standing in front of a ticket counter in your railway station or airports. So there are many different things actually. This is the place where in real life you use queues and hence the concept of queue occurs. Well, I hope so that this is very much clear. Speaking of technical usage, in terms of technicality, speaking of where we actually use queues in our technology, like what I mean to say is, let's take an example. I'm going to take an example of, can you tell me what does this logo means? Spotify. Everyone knows about Spotify. Everyone loves to listen to music, right? So we have Spotify app here. And what is this Spotify? It is a music player. It is a music streaming or music playing app or music streaming app, where you can stream music. Okay. Now it has a music player inside it. where you see the album art, you see a progress bar, you see a progress bar, and then you see a play pause button with next and previous. Am I correct? This is how your interface in Spotify looks like. Am I correct? Now here is the name of the song written, and right here there is a queue button. Right here, this queue button is present. What does this queue button does? What is the use of this queue? Very simple. It opens up a list. It opens up a list of songs which is being played right now, and which song is going to come next. All the songs are laid down into a proper sequence. Which song is playing right now, and which song is going to play next, and what song is going to come after that next song as well. I hope so that this is very much clear. So what happens in that queue is that you get to know what are the list of songs which are going to play in future or next, one after each other. That is the job of queue. Now you might have observed one thing, that as soon as this song is played, that song goes from above and a new song comes inside the queue. Am I correct? Am I correct? This song leaves the queue and a new song enters the queue. Am I correct? Okay. Now for example, let us take up an example here. I am gonna just take you towards a example. Okay. Say for example, here I am using a Spotify. I hope so that you can see it actually. Okay. So in this case, you are seeing this Spotify. Okay. I hope so that this is very much visible, right? Okay. So right here in your phone, when you play, you see right over here, I hope so that you are able to see, correct? This is the song getting played, this is the album art, this is the name of the song coming, and right here there is this button. Okay, I hope so that this is very much clear. 1 minute guys, focusing onto that subject. Okay, so right here is the album art. This is small one right here. As soon as I click onto this, you see that it changes into this, right? You see, this is the first song which is getting played right now. And now when I say next, this song is going to leave from above and a new song will come from beneath. So as soon as I click onto next, you see the queue shifted towards upwards, upside. And then the next song gets played and that song left from above. Similarly, I'll keep on clicking onto next and you see that more and more songs are keep on getting played like this, like this, like this. New songs are coming from beneath and the current song which was getting played is leaving from the above. Right? This concept is what you call as queues concept. In real technology, in our Spotify app, you are using this data structure again. Well, I hope so that this is very much clear. Okay? I hope so that this is very much clear. Okay? This is your real life queue implementation. So if someone asks you, where do we use this real life queues? You use it here, Spotify app. I hope so that this is very much clear. Okay, next up, moving on to the next one. In the queues concept, finally we are talking about the concept called as first in, first out. First in, first out. What happens in this? As I told you, the logic you have understood, that the element which gets entered into the queue first will be served first. So with the help of this, we are able to properly organize our data in such a way that we are able to do this kind of technology. We can make this kind of technology. So this is the place where we are actually using the queues data structure. But I hope so that you have understood this really well. Okay, we need to understand this. I have already explained you the meaning of this though, but next what you need to understand is how to implement it. Understood? How to implement it. That is the main concept. Okay. First in, first out. See, before I go ahead into this, we are talking about queues. Right? There are many different kinds of queues. Majorly, there are two types of categories into the queues in DSA that you need to learn. One is normal queues, and the next one is going to be priority queues. Normal queue and a priority queue. Okay. Right now, we are not learning priority queue. Yes, we will be learning this later. It is in our syllabus. This is a very, very important concept. Highly important, very important question. Priority queue, yes. But right now, this is the advanced queues. Today, what we are talking here is the normal queue. Well, a normal queue implements the concept of first in, first out, FIFO. But in the priority queue, first in, first out, understanding of this is a little bit complex. We don't exactly use first in, first out in the priority queues. But just to say that, I am going to explain it right now. We are on to this normal queues. Okay. So let's continue. So we are right now normal queues. Normal queues, they do first in, first out. Okay. In short form, FIFO. In short form, FIFO. Okay. Next up, how to implement this? We can implement a queue in a various different formats. I can use the array also. I can use the linked list also. I can use the trees also. I can use heaps also. We have not studied yet. But yes, we have studied this. So right now we are doing this. This we will do later. This we will do later. And this we will do later. So in today's class, we are focusing on two arrays. Okay. Now, finally, we are here to learn about it. Okay. How to implement a queue with the help of an array. So, guys, listen to this very carefully. I have this array. I have this array. Okay. I have some partitions into this. This is 0, 1, 2, 3, 4, 5, 6, 7. Okay. We need to make this as a queue. If I want to make this as a queue, I need to implement the concept of first in, first out. You understood this really well. So in this case, how to do this? See, guys, one thing I told you, that if you know the concept of stacks, if you have learnt the concept of stacks properly, you can easily understand queues. What had happened into stacks? Recall, in stacks, how we have implemented it? We have created an array like this. Then later on, we have created a top variable. If you remember top, we had a top variable where the top was set to -1. Correct? Remember that? Very similar to that. But in this case, I am not going to use just the top. I am going to use two instead. Number one, front, and number two, back. I am going to use two variables, front and back. So guys, because stack is actually was just closed from one side, I had to use only one variable to track the whole element in the array. But in the queues data structure, because queue is opened from both the sides, of course it is opened from both the sides, because in queues what happens, that as soon as whatever element comes into the queue first, that is served first. That means that will go out from the front of the queue. Understood? So the concept says that we are going to take two variables in this array, front and back, and they both are going to be initially initialized to -1. Alright, both of them are going to get initialized by -1, which means there are no elements into the array, of course. So next up, what we are going to do is, in queues we will be talking about number one, enqueue. Enqueue means push. Enqueue, push. Number two, dequeue. Dequeue means pop. Number three, peek. Peek, it's very similar to the top function that we have created in the stack. Peek function, which will let us know what element is gonna get deleted next up in the situation. Okay. After that, last, this is optional, empty function. It is up to you. In stacks also we have created this empty function, but you have understood this really well. Anyways, so now let us say I want to enqueue or push my first element. Let us say my first element is 5. I want to push it here. So I said enqueue, or you can say push of 5. How you will push this? The idea is that you will take this back and you will do plus plus, back plus plus. Okay, first you say back plus plus and then you push the element inside it. How you will push the element? You can use the array notation, ARR of back plus plus ARR of you have to say plus plus back, plus plus back, and you can say equals to val. Isn't it, guys? Isn't it? You will say ARR of plus plus back equals to val. In this case, what will happen is that the back will move front first, and then at that particular position the value will be inputted. I hope so that this is very much clear. Now, after your first enqueue is done, what do? You move your front also by one position, front plus plus. Why, you will get to know in a moment, just hold on, you will get to know in a moment, okay. Now I said this is done. Now I said I want to enqueue, let's say 10. I want to enqueue 10. I want to push 10 inside this. What I will do? First step, back plus plus, and then input 10. This time front will not move. Front will move only for the first time only. Front will move only for the first time only. I hope so that this is very much clear. Why so? Because you see, the first element entered will be leaving from the front. Just emphasize on my language. What I am going to tell you right now, listen to that and listen to my sentence and then understand. The element which is going to enter first will be leaving from the front. The element which is entering first will be leaving from the front. Understood? First in, first out. Well, the element which is gonna be added into the queue will go at the back of the array. I hope so that this is very much clear. So every time you enqueue, let's say every time you enqueue a number or an element, in this case, you will have to do a back plus plus. But front remains because you have not done any pop yet. When you say your first pop, when you say first pop or you say dequeue, pop or dequeue is the same thing though. Then what happens is that your front will be plus plus and this element gets deleted. I hope so that this is very much clear. You have understood this logic, guys. Everyone have understood this very important concept. Remember this, today's class lays your foundation of queues. Queues is a very important concept, guys, and later on we are gonna do priority queues as you have already shown you there in the previous example. So if you don't know queues, it's very difficult to do priority queues, and priority queues is actually the backbone of DSA, you can say. A lot of things like graph algorithms, you need to implement a priority queue. They're using heaps. So heaps should be implemented in trees first, and before you go to trees you need to do priority queues with basic linked list, and also there is a whole roadmap. If you don't know the roadmap of that, I have already told you about the roadmap in the very first session of the live stream. You can go ahead and watch that. But a very important concept, so do not lose interest in this. You need to keep on doing this. You have to understand the concept really well. Okay? Don't forget that. Understood? Next up, we are going to say we have front here and we have back here. Understood? Is that clear? Next up, as soon as you say pop, the front moves and the first element gets popped or deleted in this case. I hope so that this is very much clear. Now you said again one more pop. What will happen? This front will move plus plus and this element gets deleted. Done. I hope so that this is very much clear. Okay. Let us code for it. How does the code will work? Code will be simple, guys. You will be using, of course, object oriented programming concepts, okay, where you will be doing creating a class called as queues. The queues class attributes would be front, back and an array. Front, back and an array. In the array, you will be using dynamic memory allocation to dynamically allocate the memory and use that array as your resource array for the first one. The concept that you have understood. Then inside this class, same class, we will be creating some functions called as push, or you can say enqueue, pop for dequeue, peek, which will return the, now if I say peek, before deleting, if I say peek, it would have returned me 5 first. Right now if I do peek operation, it would return me 15, because when we peek into this array, peek will return you the element which is going to get deleted first from that queue. I hope so that this is very, very much clear to all of you. Okay? Okay, understood? One more thing guys, there are two conditions that you have missed here to understand. You see, there are two conditions. One is underflow and overflow. When does this underflow happens? Underflow will happen when back is equals to -1. Back is equals to -1. Yes, this is one case. Another case would be if front is greater than the back. If your front is greater than the back. What do I mean to say? You see, guys, at some point of time, this, as soon as you are keeping on pop, this front will of course become greater than the back. At some point of time, you deleted this element also, and this has become equals greater than, actually. This has actually become greater than the back. In that case, what happens? Again underflow, na? Underflow means it is empty. Don't forget that condition also. Okay. What will be overflow condition? Back is gonna be equals to n-1, where n is the size. This will be a hash defined n of 100. I will define it once like how we have done it in our stacks class using the preprocessor directive. I hope so that all of this logic you have understood really well. It's time for coding. So let's do coding and understand how it works. Correct? All right. Now, without any further ado, let's get right into the topic, guys, and understand. Okay. So, starting from the beginning, hash include IO stream. Okay. Using name space std. Okay. And then I'm saying class QUEUE class Q. In this class Q, class will end with a semicolon, guys, so always remember this. You already know what I'm doing here. Later on I'm going to create our main function also, and in this main function I'll write return 0 for later on. In this case, in the class Q, what are the attributes of the class Q? Array, front and back. With the help of the constructor of this class, I can initialize the memory using dynamic memory allocation using new keyword with macro substitution preprocessor directive to array, and I can say -1 initialized both to front and back, used with the help of constructor. Understood? See what I am trying to say. I am going to say here int star arr array pointer. I am going to say here int front, and I am going to say int back. There are 3 variables. Okay. Later on in the public section of the class, maintaining the abstraction and encapsulation, we protected these 3 variables. Then later on I created the constructor of the class. I said QUEUE Q, and here this is the constructor, of course. So in this case what I will do, I will say arr equals to, I will allocate the memory using dynamic memory allocation. Okay, how? I would define hash define n of 100, as I said. Okay, I have defined a macro here of n 100. I could have defined it as 10. Let's take a smaller value, 10. Okay, so the array size will be 10 in this case. I'll dynamically allocate the memory. So arr is equals to new int, and here I said n. Okay guys, this line you have understood, everyone understood? Because we are doing C++, we are allocating the memory using the new keyword. If this was C programming, you would have written like arr is equals to int star of malloc of size of int, or n maybe, whatever. Okay, but we are not using malloc, alloc, realloc. What we are using here is new. For those people who are not able to understand, please, I have also created a video on dynamic memory allocation in C++, where I have explained you about the difference between new keyword and malloc, alloc and realloc. Also I have taught this in our previous sessions. I guess in session number 2, in session number 2 of DSA, I have explained you what is dynamic memory allocation, how it is done, and why the hell I am writing this here, why the hell I am writing this line over here, what is this new keyword. So if you have missed that, please do go back into our session 2 DSA prerequisite and understand and come. If you still don't understand from there, then I would suggest you to go on to our other videos where in depth we have explained you what is dynamic memory allocation. Okay. Let's continue. So this is the place where you see array is a pointer, int star arr. I said arr is equals to allocate the memory using the dynamic memory allocation and of type int and of size n. N is a macro substitution preprocessor directive, and here we are able to allocate the memory dynamically to this particular array pointer, and this is how you do it. Understood? Next up, with the help of the constructor I have shown you this, but with the help of the constructor I also want to initialize